Hi, I'm Joanna S. Lucas from PHY124 and this is for my subject, Physics for Engineers.
Hi, I am Joanna S. Lucas from PHY124 and this video is for my subject, Physics for Engineers. In this video, I will discuss how we can find and solve a problem that is looking for its position, distance, and displacement. Of course, by solving a problem. And here's our problem. Suppose you take a trip from house A to house C and then house B. That has distance from house A to B, a 2.1 miles, and from house B to C, we have 4.3 miles. In this problem, we have three questions that we need to answer. First is what is the displacement for this trip, negative, positive, or 0. B. Find the displacement of this trip. C. What is the distance covered in this trip? So first question, we have to know where is the final position is for us to know if it is positive, negative, or 0. First and second and third questions, we have to use an equation for us to know what is the distance and the displacement of this trip. Before solving the problem or answering the questions, we have to draw the problem first for us to visualize it easily. Since our problem said that we have three houses, house A, house B, and house C. And from house A to B, we have 2.1 miles distance. And for our house B to C, we have distance of 4.3 miles. This horizontal line will be our x-axis for us to identify it easily. Since we start our travel in house A, this will be our origin. Since in x-axis, the origin means it is the 0. So our house A has value 0, or our initial position is 0. And in x-axis, we have two sides, the negative and positive, where the negative can find in the left side and the positive is in the right side. So, going back to the question number 1, we will find the displacement for this trip. It is negative, positive, or 0. Since the problem said that we start traveling at house A, then go to house C, and then to house B. So we end our trip in house B. Since our house B is still in the right side of our x-axis, our final position is positive. And it is our answer in letter A, or in our first question. Second question is asking us to find the displacement for this trip. So, since we have to use an equation, here we will use the displacement equation, and it is delta x, or change in position, equals final position, or x sub f, minus x sub I, or the initial position. As we said earlier, our initial position is at the origin. So our initial position is equal to 0. And our final position is at the house B. Since our house B has 2.1 miles, it will be our final position. Our final position is 2.1 miles. Distributing it for us to solve it, it will be 2.1 miles minus 0. So our change in position, or our delta x, is 2.1 miles. Our answer in letter B is 2.1 miles.
Last question, or the third question, we are asked what is the distance traveled in this trip. So we need to add all the distance we did in this trip. So D represent the distance equals the distance between house A to C plus the distance between C and D, since we traveled to go in at the end of our trip. So our distance from A to C is 2.1 miles plus 4.3 miles. It is equal to 6.4 miles. So as we said earlier, we go back in letter B or the house B. So our distance between house C to B is 4.3 miles. So 6.4 miles plus 4.3 miles is 10.7 miles. So if we want, we can convert this 10.7 miles into meter. Since the meter, we usually use the meter as our unit in our distance. So we should, before converting it, we should know that 1 mile is equal to 1,609 meter or 1,600.344. We only use 1,609 for us to get a result approximately. And to convert it, we will write it like this: 10.7 miles times 1,609 meter over 1 mile. Cancel the miles.
So after we cancel the miles, we will multiply now the 10.7 to 1,609 meter for us to convert it into meter. So 10.7 times 1,609 meter is equal to 17,216.3 meter. Our answer in C, or the distance covered in this trip, is 10.7 mile, and in meter it is 17,216.3 meter. That is how we can find or solve a problem that is looking for its position, distance, and displacement. That's all. Thank you for watching.